To complete any isotopic age dating calculation, you'll need references to obtain the values that you need to perform that calculation. These are the references that we will use to complete our calculations. On the left, you see a graph that shows the distribution of the parent and daughter atoms over time, and that's what we'll use to determine the amount of half-lives that have elapsed. On the right, you see a table of the more commonly used isotopes in radioactive age dating. And this will be a table that we will reference depending upon the isotopes used in the problems that we are given. On the bottom, you see the formula that we will use to make our calculation. So we will need the half-life of the isotope, which is what we will find in the table, and the number of half-lives elapsed based on the proportions of the parent and daughter isotopes given to us in the problem. That's what we'll use that graph on the left for. And multiplying these two values together will give you the numerical age of the rock based on the isotopic data that was obtained from it. Let's start our practice by using an example of a rock that was determined to contain 25% potassium-40 and 75% argon-40. Now, the first thing we want to do is refer to our table. Our table tells us that the pair of potassium-40 and argon-40 has a half-life of 1.3 billion years. That's the first piece of information that we need. The second piece of information we need will come from the graph. Now, our example has 25% potassium-40 of the parent isotope. So on the graph it says 25 atoms out of 100 of the parent atom remaining means that 2 half-lives have elapsed. So that's the second piece of information that we need. The last thing we have to do is just multiply it all together. So our first value of 1.3 billion years multiplied by 2 half-lives that have elapsed gives us a numerical age of 2.6 billion years. For our second practice, let's take a look at a really unique example. Let's take 75% uranium-238 and the daughter isotope of 25% lead-206. Now, the first thing we want to do is take a look at our table. Our table tells us that the parent-daughter pair of uranium-238 and lead-206 has a half-life of 4.5 billion years. So that's our first piece of information. Our second piece of information is obtained from the graph. Now you see on this graph we don't have an area where 75% of the parent atoms are still present in the rock, so we have to make one. And if 75% of the parent atoms are still present, that tells us that only 1/2 of a half-life has elapsed. So that's our second value that we will need. Finally, we're just going to throw this all together. 4.5 billion years multiplied by 1/2 of a half-life gives us an age of the rock for 2.25 billion years. Now, this final example was just a little bit different from some of the other ones that you will work through, but I wanted to give you an idea of how this entire calculation works as opposed to using whole number half-lives. We can also use less than 1 values for our half-lives, and so it works just a little bit differently, but the calculation is still the same. If you have any questions about how to complete your calculations using the problems that you've been assigned, don't hesitate to let me know. I'd be glad to help you.